Let's create an AI security system using Python. We import numpy for array operations, datetime for timestamping incidents, isolation forest as our anomaly detection model, and FastAPI components for the web framework, form handling, and HTML template rendering. We initialize the FastAPI application with a descriptive title and configure Jinja to serve HTML templates from the templates directory. We generate synthetic training data consisting of normal traffic and attack traffic patterns. Normal traffic uses low request rates, payload sizes, and error counts, while attack traffic uses extreme values. We then combine both datasets and ensure all values remain non-negative. We initialize an isolation forest anomaly detection model with an expected anomaly rate of 8% and train it on the traffic dataset so it can identify suspicious network activity. We create an in-memory incident log containing example safe and malicious events so the dashboard has sample data available immediately after startup. This async get route renders the main dashboard page and passes the current logs and calculated statistics to the HTML template for display. This async post route receives network traffic information from the submitted form, including IP address, request rate, payload size, and error count. We package the traffic metrics into a 2D numpy array. Use the isolation forest model to classify the traffic as normal or anomalous, and retrieve the raw anomaly score. We convert the raw anomaly score into a percentage-based confidence value and translate the model prediction into a human-readable status of either safe or malicious. We create a complete alert record containing the current timestamp, submitted traffic data, prediction result, and confidence score, then insert it at the beginning of the log list so the newest event appears first. We re-render the dashboard page with the updated logs, the newly generated alert, and refreshed statistics so the latest analysis is immediately visible to the user. We define a helper function that calculates live dashboard metrics, including the total number of analyzed incidents, the number of detected threats, and the overall system health based on the most recent security event. Now here is our index.html, where I have designed the all-user interface. If you'd like access to this code, just send me a message on our Discord server.